Hello guys, we'll be back. State teacher Edward taking you through applied mechanics under the same theme, applied mathematics under the same theme, mechanics. And we are still under the same topic, components and resultant of forces. We have looked how we calculate forces in the same direction. We have looked how we calculate the components of each individual force. We have looked how we calculate the components of combined forces, and we have looked how we are going to calculate the resultant force from the components, and then how we are going to get the angle of the components. So before me, it is one example which we are going to look at. The first one is saying a particle is acted upon by force in the horizontal plane. It is acted upon by force in horizontal plane. Let us say it is acted upon by forces in the horizontal plane. So 6 Newton force is in the direction northeast. 6 Newton force is in the direction northeast, and 7 Newton in the direction 26 degrees southeast. Find the resultant force F. 6 Newton is in the direction of northeast, and then 7 Newton is in the direction of 26 degrees southeast. So let us sketch our force. This is our solution. We have a particle. This is our particle. It is acted upon by a force of 6 Newton in the direction 6 Newton in the direction of northeast. Which one is the direction of northeast? This is our compass. This is our direction north, this one east, this one south, this one west. So this force of 6 Newton is acting in the direction of northeast, north and east, implying it acting in the middle of that direction. That is 45 degrees. When they say that in the direction of northeast, they are meaning it is acting to an angle of 45 degrees to the east. It is acting at an angle of 45 degrees to the east. So this one is our force. Should be straight line, please. Must use a ruler. This is our force, which is acting at this angle 45 degrees. 45 degrees. And then there is another force of 7 Newton. This is a force of 6 newtons. This is a force of 6 Newton acting in that direction. And then there is a force of 7 Newton in the direction of 26 southeast, implying it is coming from south to east in the direction of 26. Where is our south? It's here. Where is our east? It's this one. So we are coming from south to east. This is our south to east, but this direction moving south to east is 26 degrees. That force is 7 Newton. So the question is, find the resultant force F on the particle. Find the resultant force F on the particle. We said we consider each force independently first. We get their components, and then we calculate the resultant components, and then we get the resultant force and we calculate the angle. But here, the angle which we want should be to the horizontal. But we are all aware that this one chord of east and west take how many? This one is equal to how many degrees? Is equal to 90. So if you want to get this one, you get 90 minus the angle which is given. So here we shall get 90 minus 45. What shall be the mean width? It is 45 degrees. So this force of 6 Newton is acting at an angle of 45 degrees. Then this one also is having angle to vertical, but we need to get this one, and we also aware that this angle is also contributing to 90. So this angle here will be 90 minus 26, which I get 54 degrees. If you are not sure, if you are not trusting what we have got, get your calculator and you prove us that we are getting 90 minus 26. The answer we are getting is 64. The answer we are getting is 64. The answer is 64 degrees. So, after knowing the angles which we want, then we start resolving the forces. Let us start with the force of 6 Newton. The force of 6 Newton is a component of the force of 6 Newton. We have this force is having vertical component. Let us call it our what? We should name this component of vertical and then component of x. Let us call this component as vertical component of y due to force 6. And this one name it as horizontal component of force x, which is fx due to 6. This vertical component, which is force y for 6 force, and then we shall get this one for 7 also. So let us get vertical component. Vertical components. So we said, how do we get vertical components? We said we get vertical component by our f of y, but we are looking for the 6 Newton's force. It's given by, we said when you are getting that component, you multiply this force times the sine of the angle for vertical components. So here we shall get the force, which is 6, times the sine of the angle. Shall get the component which is 6 times the sine of the angle. What is sine of this angle? This sine is 45 degrees. So here we get the answer of our horizontal component. So use your calculator, press 6, then times, you put sine, and then you put 45. You must make sure that your answer is, your calculator is in degree, not radians. So 45 is 4.2426. At this correct to 4 decimal places. This is our force due to Fy of 6, which is 4 Newton. So this one is acting upwards. We say the force is the one having both magnitude and direction. So this one you put it is acting upwards, because here it is acting upwards. Then you come to the horizontal component. Still we are using the same formula which we said. That horizontal formula is given by, for horizontal component, we say we get f of x. F of x, but due to force 6 is given by, we say we get the force times the cos of the angle, which is 45 degrees. So use your calculator to get that answer, which is 6. Get 6 and then multiply by cos. The answer you are getting, the answer here we are getting is the same, which is 4.24226 newtons. Newtons are units of force. In which direction? We can say to the right or to the east. To the right. Then there we are done with it. There is 6, the components of 6 Newton force. Then we come to the components of 7 Newton force. Components of 7 of force of 7 Newton. Also that one is having both horizontal and vertical components. There is both horizontal and vertical components. So in our component for x, 7 Newton, our horizontal component will be x, f of x going in this direction, f of x due to 7. And this one will be f of y due to 7. So those are our vertical and horizontal components. So after getting vertical and horizontal components, you come and get their magnitude. So we shall calculate the vertical component. The vertical components, we have our f of y due to 7 is given by, say we get the force itself, which is 7 times the sine of the angle. Now the sine of this angle is the one which is 64 degrees. Then the answer you get is your vertical component. Use your calculator, calculate that answer. Shall get 7 times the sine of 64. The answer we are getting is 6. The answer is 6.2916 Newton to 4 decimal places. But where is this force acting? Is acting downwards. It's acting downwards. So horizontal component, after looking at the vertical component, you come and look at the horizontal components. Horizontal component of 7 Newton horizontal components. We are still considering a force of 7 Newton. Now horizontal component, we have named it as f of x due to 7, which is given by, say we get the magnitude, which is 7 times the cos of 64 degrees. So the answer you get is given by 7 times cos of 64. The answer is 3.06. Is 3.0656 Newton. This one is going to the right. So those are our two components. Then we are going to combine the components. Just take note of this example, then we rub it. So be taking note. So now this is our new setup. We have the particle with the vertical component, which is Fy, this one of 6 is the one acting upwards, and then we have this two acting downward. This one is f of what? F of x of 6. And then we have also another force which is acting, which is vertically downward. This force we have called it as F of y due to 7 Newton. Then there is also this force. Its horizontal component is to the right, but we have called it as f of x for 7. Then there we are going to resolve the overall resultant component and the vertical component. Follow me at the horizontal component. The horizontal component, we shall name it as Fy. The overall. We say that if you are getting resultant component, if they are in the same direction, you add. So here we shall, since F6x and then x7 is in the same direction, shall get f of x due to 6 plus f of x due to 7. This one we get, what was the value of f of x due to 6? It was 6.2426. Then the one due to 7 was 3.0656. The answer you get is 9 point. This one become 9.9 9.90 9.9082 Newton. That is our resultant component. So if you are not sure, you can use calculator 6.2426 plus 0.0656, you get that one. You get this one is 3. It is 9.0082 Newton. This one is acting to the right. And then there is this one acting to the vertical components. We look at the vertical components. Vertical components. Vertical components. So in the vertical component, we have our f of x. Our f of x is given by, in the vertical component, you say we have our f of y. Our f of y is given by f of, now here, since they are in different direction, we said we subtract. If we subtract, which one do you subtract and then which one do you subtract from the other? So you come here, you check on vertical component of 6 and the vertical component of 7. Which one is big? The one which is big, you subtract. If this one is big, we shall get f of y7 minus f of y6. If f of y6 is big, then we shall get f of y6 minus f of y7. So this one is 4.2426. And then this one is 6.2916. Which one is big? This one is greater. Then here we shall just obviously subtract y7 minus f of y6. So the answer is y7 was 6.2916 minus 2916 minus, how do you get that one? It was 4.2426. The answer is given as, you use the calculator if you can't get it. Let us see, 6.2916 minus 4.2426. The answer you are getting is 2.049 Newton. In which direction is it acting? The one which is greater is acting downward, and then the one which is less is acting upward. So the resultant force will go in the direction of big force. The big one is going downward, so this one also will go downwards. That's the direction. So now we have two forces. We have the vertical force, which is 9.6082, and then we have the horizontal force, which is 2.049 newtons. So let us finish the final answer. Get the final answer first. So now we have only two components remaining. We have components now. We have component the one acting to horizontal and the one acting downwards. So this is f of x, and then this one is f of y. Then the horizontal or resultant force will be in this direction, which is f in this direction. Let's call this angle star. So we say our f squared equals to f of x squared plus f of y squared. Then you take square root to both sides. This square root will cancel with this one. Then we remain with our force F is given by square root of f of x squared plus f of y squared. If you use your calculator after substituting our f of x was 2.049 squared plus 9.3082. This is the answer you get must be in Newton. So you shall get 2.09 squared plus 9.3082 squared. The answer you get under square root, we are getting 9.531 newtons. Then we said for a force it is a mass, we have direction. We said this one, if you extrapolate, this one become the value of Fy. So the opposite become from tan star equals to opposite over adjacent. So our tan star equals to opposite, which is f of y. F of y is given by 2.049. Then divide by f of x, which is adjacent, 9.3082. So our star equals to tan arc of the angle 2.049 out of 9.3082. So the answer is 2.049 divided by 9.3082. Tan arc is given by 12.4 degrees. Tan star is given by 12.4 degrees. So that's the angle. Then let us meet in the next example and you see how we calculate as a sense. Thank you.